Everyone, welcome back with a very interesting topic. Today we are going to study one of the most important topic from ray optics, that is the lens. Okay, and you all know that right now that we are recording here, there is a camera lens there, and I am having two lenses on my eyes, you can see. So very frequently used stuff is that and instrument is this, and we use it in many places, anywhere. When you guys will become doctor, you will have regular uses of those lenses also for your medical profession also. So this lens is such that there are many kind of lenses, thick lenses, thin lenses, but according to our syllabus we are going to study the thin lenses today. It is written lenses, but the topic is thin lenses. What are thin lenses, what types of lenses, what we have to study for that we are going to get discussed. But here one point is sure, it is a very interesting topic, you will enjoy it. First of all, what is lens? Like, how to define it? We know I can see and I can tell, okay, this is a lens, but how to define it properly in a definition? When I want, in science language, I want to say, okay, this is a lens, how I will say that? So what is that? How to define that? If someone is asking us what is lens, then we will say lenses, okay, lenses are closed refracting surfaces, having at least one of the surfaces as curved surface. Okay, so what is a lens? Basically, lens is what? Lens is a closed refracting surface. We all know what is refraction. When I am saying it is a refracting surface, we know refraction means light is going from one medium to other medium. So primarily lens is used for refracting. It is a closed surface. Like, suppose imagine a prism, glass slab, they are also closed surface, but they are plane surfaces. Now if one of the surface of a closed body, closed refracting surface is curved, we can treat it as a lens. Obviously it will be transparent, but it has to be closed refracting surface, and one of the surfaces will be curved also. So that's the proper definition of lens. Now how to draw it, how to get it? So for that we have to get the types. How many types of lenses are there? So lens you will get of two types. The first one will be intersecting lenses. What is? Intersecting surfaces. These kind of lens where two surfaces are intersecting, also you can call it as a convex. It is also the convex one. So when you say convex, what we mean to? We mean that two intersecting surfaces are there. How intersecting surfaces are there? We will have a look. We will try to understand. Suppose I am saying that this is a closed surface. That's a closed surface. Then again I have another closed surface. This is another closed surfaces. Anywhere we can take. Now when these two surfaces are closed, see carefully, are they intersecting or not? Obviously they are. And when they are intersecting, this closed surface where two surfaces are curved surfaces, that is forming a lens, which is because of two intersecting surfaces. These kind of lenses are called convex lens, right? This first spherical surface has a radius of r1. So this first surface, the yellow one, if you can see, this will have a radius of curvature as r1. The second surface will have a radius of r2. So if you can see this c2, that is the c1. So from here c2, the second surface, you can see the green surface, that will have a radius of curvature r2. So this is one kind of lenses. When these two separation, the thickness is very small, then we say that as a thin lens. When this separation is very significant, that will be thick lens. But as we have discussed, our syllabus is only thin lenses. So we will assume that whenever we are having a closed surface, the thickness of that closed surface is very, very, very small one. If it is not small, then also there is a question, but there is a different category. We will going with a very simple definition here. We can have one more discussion here, one more diagram. Please have a look. Suppose I am making one sphere here, okay, that is the spherical body, and in this spherical body I am taking another one as this, okay. Now these two, one plane surface and one spherical surface, what they are doing, they are intersecting, and when they are intersecting there is a closed surface, and this closed surface is also, you can say, plano-convex, but basically in all these we will use the term convex. So when we say convex, we are using which behavior is intersecting surfaces behavior, right? Concavo-convex or plano-convex, these kind, whenever convex is there, means two surfaces are intersecting each other. Obviously there will be one second type also. What is that second type? See the second type. In second type, suppose I am telling second type I am having non-intersecting, and whenever non-intersecting is there, non-intersecting surfaces are there, then what will happen? In non-intersecting surfaces, this you will call as concave. So when we have the name concave, the shape is there in your mind. And in convex also there will be equiconvex, biconvex, like this lens will be what? Biconvex. And if R1 is equal to R2, if that is the condition, then that biconvex will become equiconvex. But now we know that when I say convex means I am having two different spherical surfaces or one spherical plane surfaces, they are intersecting each other. Now the next one is non-intersecting surfaces. Means I have two surfaces but they are not intersecting each other. Then can lens form like that? Yes, it might. We will have a look. How? Have a look. Suppose I am taking one sphere here. Taken one sphere. Now I am taking second sphere here like this. This is the second sphere. And the separation between these two, that is filled with some transparent medium. Some transparent medium is there. That is behaving like a concave. So these two surfaces are not intersecting each other, but they are close to each other. Also gap, that gap is filled with some transparent medium, and that is forming. You can fill water also, right? So that will be water lens, glass lens, mercury lens, anything is filled there, and that will be behaving like, but it should have a transparent. If complete, like I said, mercury, and mercury suppose is completely opaque, it is not transparent, then that will not, light should refract. It is a closed refracting surface. So anything you can fill, only condition it should be transparent. Now this is having a radius of R1, that is having radius of R2, and you will have this concave lens, and this concave lens, or you can say biconcave lens, here radius will be R1, their radius will be R2. So now from this discussion we have known one thing, कि lenses are of two types. When we say use the word convex, so it should be clear in our mind that there are two surfaces who are intersecting each other. When I say concave, means plane, spherical, two sphericals which are not intersecting each other. That we should know. So if that we know, means definition of lens we have understood. Now lens have many parameters also, like refractive index is there. Refractive index is that important, you cannot ignore it if you want to discuss a refracting surface. Refractive index will decide everything. It is diverging behavior or it's of converging behavior, that we will see through refractive index. Then there is a optical center is where, or radius of curvature, or focal length. So now introduction of lens. So what is lens we got to know now? Now we will go in the introduction one. Okay, what are the other parameters of lens? And for that we will start from, we will start from this refractive index, then we will go on focus and all. What is refractive index? In general I know refractive index is ratio of speed of light right? Speed of light in a vacuum to speed of light in medium. But right now we are not discussing refractive index. What we are discussing is refractive index of lens. And is that different? Yes, it is a bit. See, suppose simply I will say what is the refractive index. We will say refractive index of denser medium upon refractive index of rarer medium. D denotes denser, R denotes rarer in general. Suppose what is water of refractive index of water, refractive index of water. So I will say 1.33 or 4 by 3 means it is with respect to air. Water upon air, denser upon rare. Refractive index of glass, when I say, then we will say glass upon air. So it is denser upon rare. In general, that is how refractive index is written. But can I take this in lenses also? Answer is no. The lens has a different formula for this. If you are writing refractive index for lens, you need to write refractive index of material divided by refractive index of surroundings. A refractive index of material upon refractive index of surrounding. That is very important. We have to get this very well because this will decide the behavior of lens. For example, suppose I am taking, a convex lens. I am taking convex lens. In general, there is a misunderstanding or you can misconception कि convex lens is like it's a converging lens or concave is a diverging lens. That is a common misconception. It should not be there in your mind now. From name you cannot decide. Name is convex means there are two intersecting surfaces, that's it. So convex is converging or diverging. I will be very clear in my mind, in my head, कि from name I will not decide. I will have to go in refractive index to understand कि nature is converging or nature is diverging. For that, how we would know? Convex lens I am taking. See, that is a convex lens. In this convex lens, in that convex lens, suppose I am saying कि mu lens material is greater than the mu surroundings. अब surrounding could be air or surrounding could be any other medium, but that material mu, crown glass is there, flint glass is there, water is there, the material refractive index is more than the surrounding refractive index. In that case, material is more than surrounding. In that case, mu lens will be greater than 1. Means lens is denser as compared to the surroundings. So in this case, convex lens is converging lens. Convex is converging lens. Means if I am drawing the diagram, if rays are coming like this, rays are coming like this, rays are coming like this. So these all rays will converge at a point. Obviously that point is called focus and that length is called focal length, but that is a secondary discussion. Right now we are just into is convex converging or diverging. We have got the concept. From name we will not decide. We will see the refractive index. If material refractive index is more than the surroundings, then mu lens is greater than 1. In that case, convex is converging lens. Got it? But the same one, see, now if I am saying for convex only, if mu of the material is less than the mu of surroundings. Now your surrounding mu is more, and whenever surrounding mu is more, material mu is less, mu lens will be less than 1. Mu lens will be less than 1, and as it is less than 1, then your convex lens, the same lens will be diverging. Many times in PYQs of JEE and NEET, you might see these kind of question where they will simply give you the diagram to pick. It is going like this. Is that the correct one? Is this diagram correct one? I will give outside suppose mu 2, inside I will give you mu 1, and I am saying mu 2 is greater than mu 1, surrounding mu is more, then this diagram is right. convex becomes diverging. So convex, again, very simple basics of lens we will take in our head. We will not decide nature of converging or diverging by just mere knowing the name. What we will do, we will go on the refractive index comparison. Mu lens can be greater than 1, can be less than 1, can be equal to 1. That's not the case in otherwise. Otherwise, mu denser by mu rare you are writing apart from lens, water or oil or glass, simple material refractive index. When we write mu denser upon mu rare, and that is always greater than 1. I am not talking about relative refractive index. Material refractive index is written that way. But lens could be greater than 1, less than 1, equal to 1, that is relative. Okay, where you have placed that lens. So this is the nature of convex lens, that might be converging, that might be diverging. We have got the proper condition also. Similarly, we will see the concave or biconcave, concave lens. Now, if we are going in concave lens, in concave lens, how the things goes, see, this is the concave lens, and generally we know that concave lens is the diverging lens. But now we have learned that from name of the lens, we will never decide it is converging or it is diverging. We will always compare the refractive index of material with that of the surroundings. So if I am doing that, what I am getting here, one ray is going, and that is going, and that is diverging. According to the law of refraction, if your rays are going away from the normal means you are into the rarer medium. So denser to rare you are going, then it is away from the normal. In that case, what happens? If mu material is greater than the mu surrounding, or mu of lens is greater than 1, if that condition obeys, then concave becomes diverging. So when is the concave diverging? When mu material of lens is more, it's denser. And in that same case, if it is convex, that will be converging. But if you will have a concave lens, this, and here ray is going, this is going like this, and here they will converge, or they might converge, because the mu material is now less than the mu surroundings. So understand, convex behaves as converging in a case, in the same case concave behaves as diverging. But if you will just switch the condition, you will change the condition, oppose the condition, then it will be other way around also. So always, it's my simple suggestion to all of you students working preparing for NEET, don't just memorize the converging, diverging from the name of the lens, always go for surrounding. Convex is converging when mu lens is more, but concave is diverging when mu lens is more. If these conditions are not obeyed, they will behave in different manner. So we understood here in this slide particularly what is the refractive index of lens. This formula, it is different from the normal medium refractive index, and what this refractive index decides, it decides whether a given lens is converging or diverging. So that we have got in the second slide. After this, as we were discussing, we have to discuss the other parameters also, how lens, information about lens, how lens will be studied. So first we got definition, then we got refractive index. Next we will get this principal focus of lens. You see, if you will see all the numericals, all the formula of lenses, you will find focal length everywhere. Yes, you can prepare that way, you can have that thought in your mind. I am using lens formula, 1 by V minus 1 by U is 1 by F, focal length is there. We are using lens makers. Lens makers is what? See, let me write for you, 1 by V minus 1 by U, 1 by F. Just try to focus how important is focal length. Or I am using lens makers, 1 by focal length is mu lens, and now you know mu lens means mu material by mu surrounding, minus 1 by R1 minus 1 by R2. Or we are using the displacement method, Displacement method, if you are writing focal length as d square minus x square by 4d, then cutting of lenses, combination of lenses, means everywhere in all formula you will see focal length, focal length, focal length. Without focal length you can't have a formula. Even in magnification also focal length is used. So it's my very simple suggestion to all the students who want to get numericals of lens right, be very aware of focal length of the lens. This parameter is missing, your entire numerical of focal length will be missed. Okay, so let's start. What is that topic? That topic is, okay, we are writing here, dekhte hain. So we were doing what? We were discussing principal focus. Now see, what is principal focus? Lens has how many surfaces? If I am taking for reference, we are taking convex lens. So this convex lens, we can see there is one surface here and one surface here. So total the lens have two surfaces. Now lens have two surfaces, so obviously it will have two focus. Lens will have two focus. One focus is this. Let's have a look. One focus is this. Suppose here I am putting one object and rays are going like this. After refraction from lens, you can see I am taking refraction from the midpoint, as it is a thin lens. All like it will have two refraction, one here, but since it is very thin, I am taking it from midpoint and it will go like this. Then again from here it is going like this. When the rays becomes parallel to principal axis, V is infinity and 1 by V minus 1 by U is 1 by F. So V is infinity, so minus 1 by U is 1 by F. So object length becomes one focus. That is one kind of focus. Got that? So one focus is I can say that position of object for which what happens? That position of object for which image goes to infinity. Image tends to infinity. Okay? So this is called focus and its name is primary focus. As we discussed, lens has two surfaces and two surfaces means it will have two focus. So position of object for which image becomes infinity, position of object for which image becomes infinity is called one focus, and that focus is called primary focus. Okay, simple. Just supposing what is primary focus of lens is, and in NEET they are asking us question position of image, position of object, position of both, we should know it is position of object. Now second diagram we are discussing the same one, in which what is happening, that one light is coming from infinity, means object is at infinity, and that's the principal axis. It is coming from infinity, and when it is showing refraction, they are hitting a point, and that point is the focus, and this focus is called secondary focus. This is called secondary focus, and secondary focus you can see it is after refraction or after reflection, lights form images. So I can see here refraction is taking place through lens. What lens is doing? Lens is refracting it. So when lens is refracting it, image is formed. So secondary focus is position of image for which object is infinity. So we can say what is secondary focus? Secondary focus for lens is whose position? Position of image for which, this is important, position of image for which object is at infinity. So V is equal to secondary focus with the condition U is at infinity. So these are the two focus in the lens. Primary is the position of object for V equal to infinity, and secondary is position of image for object at infinity. But if you have a lens, like suppose this is the lens we are having, this is the lens we are having, and left side medium, this medium and this medium, both are same, medium, like this is mu, this is also mu. If medium on both sides of a lenses are equal, then primary focus is equal to secondary focus. That is one point we will keep in mind. If both the sides of lens, mediums are same, then primary focus is equal to secondary focus. That is the point number one. Second point we will keep in mind, that simply we say na focal length or focus, so that in general secondary focus is the principal focus. Secondary focus is the principal focus. So when we say what is the principal focus, that is the position of image for which object is at infinity. Although the numerical value, if both medium are same, numerically they did 10 centimeter, secondary is also 10. Numerically they are equal, but that is a statement question you can expect from that. Which focus is the principal focus for lens? Keep in mind, it is always the secondary focus, and it is position of image for which object is at infinity. So that is the basic example of this, and if you know this point is the secondary focus and this is called principal focus. So from optical center to this, that distance is called focal length. So that is becoming focal length. That focal length is distance from optical center to the principal focus, that is the secondary focus. Optical center is also a very interesting point, how to define optical center. But before that, focus we have understood, principal focus is the secondary focus, and lens have two surfaces, so obviously they will have two focus, one is primary, one is secondary. They are not always same, they are only same when medium in both sides will be same. Okay, that we have got. We will see the next one. Refractive index is done. Seeing one more thing here. We were discussing about optical center. Let's have a concept about optical center. Optical center. What is this? It is a very interesting concept. All the measurement in lens we do from optical, like you have to measure image distance, so you will measure from optical center. Object distance, focal length, just we have discussed, principal focus is measured from optical center. But the point is, what is optical center? So you will have a basic theoretical concept. It is a point from which rays pass undeviated. Rays pass undeviated. This is optical center, and from here rays are passing undeviated. What direction you are putting it, that does not matter. But if this is the optical center and rays are incident, so rays will refract, rays will pass undeviated. So that is the first point we can say, optical center, a point on thin lens from where rays pass undeviated. That we got, undeviated. Okay, but there is one more definition, very interesting definition. See what happens. Suppose you have a lens. This is the lens you have, and here this surface has a radius of curvature R1, and this surface will have radius of curvature R2, let's say. And obviously the surface number 1 will have some center of curvature, and surface number 2 will have some center of curvature. This point is P1, this point is P2. Optical center is O. So there is one more definition. What is optical center? Optical center of lens, for theoretical question, I think it is a must known term. Optical center of a lens is a point that divides distance between the poles, distance between the poles in the ratio of their radii of curvature. Radii of curvature. Got it? Now what we have written, we will see according to the expression what we can say. What I am trying to say, optical center is a point that divides the distance between the poles. This is one pole P1, this is one pole P2. So OP1 upon OP2, where O is the optical center, OP1 upon OP2, that will be R1 upon R2. Got it? That is the proper definition. Maybe numericals in it will not come, but if it is not thin lens, you cannot have that in equiconvex lens also. Equiconvex lens also, R1 is equal to R2. You can think it is at the midpoint, but I want many of you to get that misconception clear. कि optical center is not always the midpoint. It might lie anywhere. Like in biconvex, where R1 is not equal to R2, optical center will not be the midpoint. It will be very near to the midpoint, but it will not be midpoint. So optical center only comes in midpoint if R1 is equal to R2. If R1 is equal to R2, then OP1 equal to OP2, then optical center is the midpoint. So just for theory questions or statement questions, we should know it. If I have a biconvex lens which is not equiconvex, then I cannot say that optical center will be at the midpoint. So that is also very, very important. Although in numerical solving we will always consider it as midpoint, because we are dealing with thin lenses where the pole P1, P2 distance is very, very, very small. But conceptually, theoretically, it is very, very important. So we have understood the refractive index. See the how sequence is going. What is a lens, we know. What is the refractive index of lens, we know. After that, we have done the principal focus is the secondary focus, although there is a primary focus also. And then what is optical center? So this is why this is a very basic concept of lens. Slowly we will get on to the numerical topic and all, but theoretical points, to be clear, the conceptual points are very, very important. After that optical center, we will go on this, the rules for image formation. This should be your sequence. Although we can discuss it, suppose we have not memorized, we can discuss it, we can do it ourselves, but some point we will discuss here. Like suppose I am taking, you can see I am taking a convex lens. Convex lens, position of object is infinity, we have discussed, that is the secondary focus. Position of image is F. Now just imagine it is asking you a question in this. Position of image is principal focus, secondary focus, both A and B, primary focus. So you will take C option, both A and B, because principal is secondary. Got that? At F. This F is the principal focus, which is also the secondary focus. Real, inverted, diminished. Now just one basic discussion we will make on real, inverted and diminished. Real means when lights are refracting, that is the lens, from the lens, image will be formed because of refraction. Lens is a refracting device here. So after refraction, these rays, are they actually meeting here? Are they actually converging here? Or they appear to get converged? So we can see they are actually converging here. This actual convergence is giving you the idea that image is real. We got that? Image is real because rays are actually converging there. So real we got. Now we are getting here inverted. Inverted means, please understand, magnification when you write, you are writing V by U. That is the raw formula. Always memorize raw formula and put sign according to the situation. Since V is formed because of which ray? I would say refracted ray. And U is formed because of which ray? Incident ray. You can see incident ray is going where? Right. Refracted rays are going where? Right. Both rays are going right. So the direction of propagation is same. That's why V and U both in raw formula are plus. In reflection what happens? In mirror what happens? Mirror is reflecting it back. So U is like that and V is like that. So they are moving in opposite direction. So we write minus V by U. But for lens, the raw formula without any situational sign convention, M will be V by U. That is the condition. Now, You see here, your u is at infinity, so obviously u is more than v. U is more than v because u is at infinity, and u is more than v, then magnification will be less than 1, and when denominator is more, no, so magnification is less than 1, then it will be diminished. Enlarged means it is zoomed 1, it is magnified. So magnification less than 1, that is only can be done by comparing the magnitude, the numerical value of u and v. Now real we got because rays are actually converging. Diminished we got because u is more than v, so it is less than 1 diminished. How I will get inverted? So now as I said you, m is the raw formula. If I am putting sign from optical center, I am measuring I, and I is measured in the direction of ray, that is v, and this is measured, object is measured opposite. So object will be opposite means negative and image will be positive. So what I will write here, magnification I will write as v by minus u, it is negative, and negative means inverted. Negative means inverted. So make a table and decide how we are going to decide real. Actual convergence is real, apparent convergence is called virtual. Inverted means u is more than v, u is denominator is more than, and diminished means inverted means negative, and diminished means u is more than v, and real means actual convergence. Same in other case also, if you will do each case by this, you will not have to memorize it, you will be able to analyze in any case. Suppose I am saying the second case. Now here your object is at f. Where is your object? Object is at f, you can see. Object is at f, so image is at infinity. Position of image is infinity. Now see, if position of image is at infinity, how to go in that? We can have this diagram, this diagram. In this diagram what is happening? Object is at focus. So object is at focus, I am taking object at focus, and rays are going like this, and it is at infinity. Now you can see the v is infinity and u is equal to f. Obviously infinity is more than f. Infinity is more than f. So here u is less than v. V is more, so magnification is more than 1, and more than 1 means it will be highly enlarged. Enlarged is the obvious, highly because v is infinity. So that's why m magnitude comparison of u and v, m is more than 1 is enlarged, less than 1 is diminished. Then real rays are actually here going or apparent going, actual, so it will be real. And how I will get inverted? When they are on either side, one is like object is one side of the lens, on image is other side, it is always inverted because v and u will have opposite sign, and opposite sign means m will be negative and it will be inverted. So like this we will analyze each and every point if we can go with this. So today we have spent our time in discussing the basics of lens. Next class we will meet, we will go on numericals now, and we will start the numericals from lens maker formula, lens formula, displacement method. So for numericals and all, we will have one more session. Today we have discussed the basic definition of lens. Hope you enjoyed it. Okay, bye bye, take care, bye.